All right, this is Algebra 2 OAS A2A21. The student will factor a difference of cubes. This is going to be very, very similar to what we just did for the last couple of days. Instead of factoring a sum of cubes, we're going to factor a difference of cubes. A difference means that they're going to be subtracted rather than added. This is lecture 11.4 and 11.5. Again, the cubes that we're going to be working with will be the result of a monomial having been multiplied by itself 3 times. For instance, again, this is just exactly what we did with the sum of cubes. 2 times 2 times 2 is 8, therefore 8 is a perfect cube. 2 is the cubed root of 8. X times x times x is x to the third, therefore x to the third is a perfect cube, and the cubed root of x to the third is x, because that's what you multiplied by itself 3 times to give you x cubed. 3x times 3x times 3x is 27x cubed, therefore 27x cubed is a perfect cube. And the cubed root of this would be 3x, because that's what you're multiplying by itself 3 times to give you this. We're going to be running into the same cubes that we ran into with the sum of cubes. We run into these cubes all the time. There are obviously an infinite number of cubes, but these are the ones you run into a whole lot. 1, 8, 27, 64, 125, 216, 343, 7 cubes, 6 cubes, so forth and so on. And if I said, well, what's the cubed root of 343? You would tell me 7, because 7 times 7 times 7 is 343, so forth and so on. These are the perfect cubes we're going to keep our eyes open for, and their cubed roots. To factor a difference of cubes, this is so very similar to a sum of cubes. The only difference is exactly like the sum of cubes with one difference. The placement of the plus and minus signs is different in a difference of cubes. In a sum of cubes, the first one was a plus sign. We pre-placed our plus signs and minus signs. The first one was a plus sign. The second one was a minus sign. And the third one was a plus sign. There was only one minus sign, and there's only one minus sign this time. When we go to pre-place our plus and minus signs, if this is a difference of cubes, the first one's a minus sign, and the next 2 are plus signs. And we're going to use the exact same pattern as a sum of cubes. And I'm going to go ahead and demonstrate that a few times, and here we go. I have a difference of 2 perfect cubes. That's x times x times x. That's 2 times 2 times 2. So I'm going to use the pattern that's established above. It's going to be a binomial times a trinomial. I'm going to pre-place my plus and minus signs. I'll give myself a little bit more. Pre-place my plus and minus signs. If that's negative, this is a minus sign. And the next 2 are plus signs. I can't stress that enough. In sum of cubes and difference of cubes, when you go to pre-place your plus and minus signs, there's always just one minus sign. Putting it in the right place determines whether you're going to get your factorization correct or not. We follow the exact same pattern as, now from here on out, it's just like sum of cubes. Take the cubed root of this one. That's the thing that's being multiplied by itself 3 times. Put it here. The cubed root of x cubed is x. Put the cubed root of this one. That's the thing that's being multiplied by itself 3 times. It'll give us an 8. Put the cubed root of this one here. So the cubed root of 8 is 2. And we're done with these. To fill in these 3 blanks, we take this one and square it. X times x, x squared. Then for this one, we multiply these 2 together. We've already pre-placed our plus and minus signs, so don't worry about that. Just 2 times x is 2x. And then for this one, we square this one. And again, we pre-placed our plus and minus signs, so don't worry about anything else. Just 2 times 2 is 4. And we've got it factored. It's the exact same pattern as the sum of cubes, with the exception of the placement of the sole minus sign. There's only one in difference of squares, and there's only one in sum of squares. So don't make the mistake of having more than one minus sign. There's only one. Let's look at this one. Here's another difference of 2 cubes. And I'm going to factor it using the exact same pattern. I'm going to go binomial size set of parentheses times a trinomial. Pre-place my plus and minus signs. If this is negative, this one's negative, the next 2 are positive. I take the cubed root of this one and put it here, the cubed root of this one and put it here. The thing that's being multiplied by itself 3 times, that's the cubed root. That is 4a. 4a times 4a times 4a is 64, a cubed. So 4a goes here. The cubed root of this. The thing that's being multiplied by itself here is 1. 1 times 1 times 1. That's the cubed root of 1. Now I'm done with this. To fill in these three blanks, I square this one. 4a times 4a is 16a squared. Multiply these two together. 4a times 1. Again, we've already pre-placed our plus and minus signs, so don't call it negative 4a. 4a times 1, 4a. And then we square this one for this blank. 1 times 1 is 1. And unless we've made a mistake with our arithmetic, we've got this difference of two perfect cubes factored. This times this will give me that. Now I'll do a couple more here. I have a difference of two perfect cubes. That's 3u times 3u times 3u. That's 4 times 4 times 4, right? I'm sorry. That is 6 times 6 times 6. I don't know why I was thinking 4. So I'm going to have a difference of two perfect cubes. That'll be a binomial times a trinomial. I pre-place my plus and minus signs. That's a minus sign there. And then the next two are positive. And then I fill in these 5 blanks. This blank is the cubed root of this one. The cubed root of 27u cubed is 3u. Because 3u times 3u times 3u is 27u cubed. The cubed root of 216 is 6. Because 6 times 6 times 6 is 216. Now I want to fill in these blanks, and I'm through with this. I don't look at this anymore. I just square this one. 3u times 3u is 9u squared. That gives me that one. Multiply these two together. 18u. We've already pre-placed our plus and minus signs, so don't worry about that. And then we square this one for this. That would be 36. 6 times 6. And, unless we've made an arithmetic mistake, we have factored this difference of perfect cubes into these two factors. This quantity times this quantity will equal this. And here's one more. I'll run through it using the exact same pattern. All I'm doing is doing the same thing we did with sum of cubes, but the placement of the single minus sign is different. Okay? So here we go. I'm going to factor this. I see that it is a difference of cubes. This is x times x times x. That's 5 times 5 times 5. So it is a difference, meaning subtraction, of two cubes. So we're going to factor it using that pattern. Pre-place our plus and minus signs. That's a minus sign, plus sign, plus sign. And then we just got to fill in the blanks with the right values. And we just follow the same pattern that we did with sum of cubes and the other difference of cubes patterns. Determining what goes in these 5 places is the exact same thing we did with the sum of cubes. The only difference is the placement of the sole minus sign. I take the cubed root of x cubed, that's x. I take the cubed root of 125, that's 5. I'm through with this. I square this one to put it here, multiply these two together for here, and square this one to put it here. X times x, x squared. X times 5, 5x. 5 times 5, 25. And again, we've already pre-placed our plus and minus signs, so we don't go x times negative 5 is negative 5x. Don't do that. We pre-place the plus and minus signs in such a manner as so that if I multiply this times this, I'll get that. And that's what I'm going to demonstrate right now, just like I did with sum of cubes. I'll just use this one to demonstrate that this pattern actually works. I'm going to take this x, distribute it throughout this quantity. This will give me x times x squared, that's x times x, that's x cubed. X times 5x is positive 5x squared. Excuse me. X times 25 is positive 25x. And then I'm going to take that negative 5 and distribute it. Taking the negative 5 and distributing it. Negative 5 times x squared is negative 5x squared. Negative 5 times positive 5x is negative 25x. And negative 5 times 25 is negative 125. And when I go to combine my like terms, 5x squared and negative 5x squared will turn to 0. 25x and negative 25x will also turn to 0. When you add them together, if you add opposites, you always get 0, just like we learned in pre-algebra. And that leaves us with two terms that won't combine because they're not like terms, and that's x cubed minus 125, which is what we would expect to get if we factored correctly. When we factor something, we break it into two parts, or more than two sometimes, but we break it into chunks, so to speak, factors, such that if I multiply them together, I get what I started with. And I just demonstrated that this times this is indeed this. And that will work for all of these, unless we've made arithmetic mistakes, and I don't think we have. So with all of that in mind, the difference of cubes pattern is what we're studying today. Here it is in a nutshell. Very similar to the sum of cubes problems, and I know you can do this.